Friends, myself Anil Kumar Singh. In this video, I will explain how to convert noisy time domain signal to frequency domain signal. So, just I am clicking on Matlab tool, right click and click on open. In previous video, I have explained how to convert sinusoidal mixed time domain signal to frequency domain signal. Now, in this video, I will explain how to convert noisy time domain signal to frequency domain signal. Okay, so just close all this open file. See, I have already coded FFT of noisy signal. This is the FFT of noisy signal.m. This is the Matlab file where I have written all the code for converting time domain signal to frequency domain signal. I will explain line by line. Please watch carefully. Okay. In first section, I have written three commands: CLC close all, clear all, to clean the workspace and command window. In next section, I have defined the parameters: sampling frequency of 2K, FM message signal frequency of 50 Hz, sampling time of 1 by Fs, it means sample period, and FFT point of 1024. I have taken FFT point of 1024. You can take any power of 2. You can take 64, 128, 256, 512, 1024, 2048, 4096, like this. Should be power of 2. And define the time vector t equal to 0 to FFT point. Whatever how many sample we are taking, 1024. So I have defined here NFFT minus 1 because I have started with 0. So I am time vector I have defined for 1K sample 1024, and each sample period is TS. Okay. In next section, I have generated the sinusoidal signal. I already explained in the previous video. In second section, I have generated the noisy signal by adding the random number to sinusoidal signal x1t to generate the noisy signal. I have already explained in the previous video. So, if you have not watched, please watch the previous video, then watch this video. I will explain this, how to convert this noisy time domain signal to frequency domain signal. Okay, so here fast Fourier transform. I am using fast Fourier transform FFT. I am using FFT Matlab function for converting time domain signal to frequency domain signal. So here yt is noisy time domain signal. See here, already I have defined here yt equal to 10 to the power minus 4 into x1t plus 1 into 10 to the power minus 5 into rand n. This is rand n is the variable to define the random value, and which size of t. T is the time vector. Okay. So this yt is the noisy signal. Just I am converting this noisy time domain signal to frequency domain signal by using FFT Matlab function. FFT of yt, NFFT, FFT point. I am passing these two arguments to FFT. It will perform FFT. Then we are shifting. Then once after FFT, just do the FFT shift. It means shifting the FFT by FFT point by 2, NFFT by 2, and assign this FFT shift value to shift FFT out. This in this variable we can rename any value, any This variable name can be anything. I have written here shift FFT out, and also I have defined axis, and I have also defined x-axis level, because of in frequency domain x-axis is frequency and y-axis is magnitude. So I have defined here x-axis as in terms of frequency. X-axis will be FFT point. FFT point is NFFT. So due to FFT shift, I have defined x-axis level from minus NFFT by 2 to NFFT by 2 minus 1. Okay, and I have multiplied with frequency resolution Fs by NFFT. This one represent FFT resolution, and I have assigned this value to n value. Okay, then I have plotted here. Plot n value, comma, absolute value of shift FFT out. Okay, absolute value means magnitude of this shifted FFT output, and I have titled as FFT of noisy signal. X-axis level as negative and positive frequency, and Y level I have defined as magnitude of DFT. Okay, so these are the code for generating the noisy time domain signal and frequency domain signal. Now I am running this code, and I will see how a spectrum and time domain signal look like. Just click on run, just double click on run and see. See, this is the sinusoidal signal, and this one is the noisy signal. I have already added some noise to this signal. So see, just I am zooming this signal. Okay, so this is the noisy signal. Just zoom section of waveform so that we can see easily. Okay, see, this is the sinusoidal signal. In this sinusoidal signal, I have added some random noise. So this sinusoidal signal is added with some noisy signal. So time domain signal look like this. This is the noise which is added to the signal. Okay, now see the spectrum of this noisy signal. Due to noise, these are the spectrum of the noise. This is distributed uniformly over complete FFT point, complete frequency range. Okay, this is the signal frequency. Just zoom it, see, 50 Hz, 50 Hz signal frequency. We can see in the code also. I have generated one signal having frequency of 50 Hz. So here we can see the 50 Hz frequency exact. So in this way we can perform FFT of noisy signal. Okay, all these things due to noise. This is noise spectrum. This one is the signal spectrum. Okay, combinedly noisy signal spectrum. Okay. Okay, in next video I will show inverse Fourier transform of sinusoidal signal. Thank you so much for watching my video.